Hi class, today we will be learning about the muscular system. Please find the corresponding notes and follow along. Let's start with two quick facts. Did you know we have over 640 muscles in the human body? We'll learn a good amount of muscles, but we're primarily going to learn them as muscle groups in Sports Medicine 1. We'll dive deeper into the individual muscles when we get to Sports Medicine 2. Another fact, did you know our muscles make up about 40 to 45% of our body weight? So if we were to jump on the scale, again, that scale is measuring a bunch of stuff, right? We have our muscles, our skeletal system, all our other systems in our body, our water, etc. But our muscles make up 40 to 45% of our body weight. The functions of the muscular system include number one, holding up the body and making movement possible. As we talked about previously, we have a skeletal system, right? It's the framework of our body and it protects our internal organs, but that skeleton is not going to stay erect or be able to stand up or even move without the muscular system. The muscles we're going to learn are going to contract and relax and allow movement to occur. The second function here says muscle movement generates 85% of the heat that keeps our body warm. So there's a certain core temperature we like to keep so that way our body is maintaining at its best of its ability. And our muscles actually generate 85% of that heat. You probably heard of the team, hey, go run and get warmed up. Well, when you are using your muscles, we're generating heat that we need. The third one here says the muscular system helps move food through the digestive system. Now, we haven't really touched very much on the digestive system, but it's a system that ingests and basically breaks down and digests our food. And essentially, in order for the food to continue to move through that system, we have muscles actually lining the digestive system to help push the food into where it should go. The fourth one here says the muscular system aids in the flow of blood through veins as it returns to the heart. Same thing, the cardiovascular system is incorporated with the muscular system because the muscular system helps the blood go ahead and pump and flow through the veins as it returns back to the heart. And we'll get into that further when we hit the cardiovascular system. Now, when we talk about muscles, we also want to talk about muscle tissue. There are actually three types of muscle tissue. We have cardiac muscle tissue, skeletal muscle tissue, and smooth muscle tissue. There'll be a slide for each of these. Let's begin with the cardiac muscle tissue. The cardiac muscle tissue is going to be located in the walls of the heart. Cardiac sounds like the root word cardio, and they both mean heart, where cardio means heart. Cardiac muscle tissue is basically heart muscle. Cardiac muscle tissue is muscle tissue found in the heart. Next, it says striation here. Striation, we're looking at basically like the stripes. If we were to take a piece of cardiac muscle tissue, put it underneath the microscope, we'll notice that it is striated. Striated means to have stripes. So notice here in this picture, this is a cartoon version of cardiac muscle tissue. You'll notice there's alternating light and dark pink lines. That striation or stripe is going to help us indicate that we're looking at a cardiac muscle tissue. Also, when we look underneath the microscope, you're going to see this kind of like spider web. You'll see some other images of muscle tissue in the next two slides. You'll notice this one looks a little bit different. Next, we're talking about the contraction of muscle tissue. Our cardiac muscle tissue contracts involuntarily. Involuntarily means without choice, right? If you volunteer, it's by choice. Involuntarily means without choice. So cardiac muscle tissue, again, is muscle tissue that is found in the heart. If we were to look underneath the microscope, it would look like this spider web looking thing, but it would also have striations or alternating stripes. And how does it contract or squeeze? It squeezes or contracts involuntarily, which means without choice, which obviously was what we want. The muscles of our heart helps kind of give us our heartbeat, pump our heart. And we don't really want to sit here and be thinking and telling our brain, pump our heart, pump our heart, pump our heart. Instead, these muscles actually work independently and they are contracted involuntarily. The next type of muscle tissue we have is the skeletal muscle tissue. The skeletal muscle tissue is located in our muscles. It has a little asterisk because when I talk about muscles, because obviously there's different places where muscles found. In this case, I'm talking about the muscles as we know as like the bicep brachii, the tricep brachii, the quadriceps, the hamstrings, etc. So those muscles are made up of skeletal muscle tissues. And if we were to look underneath the microscope, we'll notice the striation is striated. So over here, here's the image. Notice this one doesn't look like a spider web. It looks like parallel tubes. This is one way we know we're looking at skeletal muscle tissue, but also when we look underneath the microscope, notice there's alternating dark and light lines. That means it's striated. Now, this type of muscle tissue, skeletal muscle tissue, actually contracts voluntarily, which means by choice. Now we know that. Let's think about it and apply it. If we're talking about a muscle, we can talk about one we probably know already. Right here in the front of our humerus is a bicep brachii. Our bicep brachii is going to flex our elbow. Now, anytime you want to flex your elbow, it's by choice, right? It's not like you were sitting watching TV and all of a sudden your elbow just flexes out of nowhere, because skeletal muscle tissue contracts voluntarily or by choice. The next type of muscle tissue we have is smooth muscle tissue. Smooth muscle tissue is located in our organs, so like our liver, our kidney, etc. All our organs except our heart, because as we just learned, the heart has its own muscle tissue. It's called cardiac muscle tissue. Smooth muscle tissue is found in all the other organs. If we were to look under a microscope and look at smooth muscle tissue, in my opinion, it looks like green beans, like in those fresh green beans that you get at like the store. Of course, they're pink here, but you get my drift. And if you were to look underneath the microscope, you'll notice that they look totally different than the other two muscle tissues in general, but also that they are unstriated. There is no alternating dark and light lines. Smooth muscle tissue, just like the cardiac muscle tissue, contracts involuntarily, which means without thought or without us really having to make that choice, which again is great. We want the muscles that outline or align like our stomach, etc., to go ahead and work independently so we don't sit here thinking constantly about getting that contraction to occur. So, brief summary here. On the left, we have the cardiac muscle tissue. The cardiac muscle tissue is found in the heart. It looks like this underneath a microscope. Looks like a spider web and is also striated, which means alternating dark and light lines. Cardiac muscle tissue found in the heart contracts involuntarily, which means on its own, which is great because we can't just be thinking about our heartbeat for the rest of our life. In the middle here, this is skeletal muscle tissue. Skeletal muscle tissue is found in the muscles we know as the bicep brachii, the tricep brachii, the quadriceps, the hamstrings, etc. Underneath the microscope, it looks like this. So notice instead of a spider web looking thing, it looks like parallel tubes, but also it is also striated like the cardiac muscle tissue. This skeletal muscle tissue does contract voluntarily, which means by choice, which obviously we like. We don't want our arm to just randomly flex. We want to be in control. And lastly here, this is the smooth muscle tissue. It's found in all of your organs except your heart because it has its own muscle tissue. And if we were to look underneath the microscope, it looks like pink green beans, but also you'll notice there is no striation at all, which means no alternating dark and light lines. Smooth muscle tissue, just like the cardiac muscle tissue, is contracted involuntarily or without thought, which again is awesome because we can't be sitting here always thinking about our stomach or organs squeezing and moving food, etc. Now, when we are talking about the muscles for this class, primarily we're going to be referring to the skeletal muscle tissue. We're talking about the skeletal muscles like the bicep brachii, the tricep brachii, the quadriceps, the hamstrings, etc. All those muscles have something called an OIA. O stands for origin, I stands for insertion, A stands for action. Every single muscle in our body has an O, I, and an A. Now let's talk about what OIA stands for. O stands for origin, and the origin of a muscle is where a muscle starts. I stands for insertion. The insertion of a muscle is where a muscle ends. A stands for action. Action of a muscle is the movement the muscle performs. So for example, we're looking right here at the tricep brachii. This is the posterior aspect of your right arm. This is the tricep brachii. If we look at the image, you'll see that there are three origins. When we learn about the tricep brachii, we'll learn that the tricep, remember tri means three, has three places of origin or three different places that it starts at. Then you'll notice that there's only one insertion. There's only one insertion for all three of those tricep brachii heads, and that is where the muscle ends. The action of the muscle is what the muscle actually performs. Essentially, when a muscle is trying to be used, the insertion moves closer to the origin. So the action for the tricep brachii is elbow extension. Another thing we can note is the difference between the origin and the insertion. As we can kind of see in these images, or just by thinking about it, a muscle has to start at one bone and end at another bone. But how do we know which one's the origin and which one's the insertion? Well, typically the origin is found on the more stationary bone, while the insertion is found on the moving bone. So for example, let's briefly talk about this muscle called the hamstring. The hamstring is a group of muscles. For the sake of this class, we're going to be referring to them as the hamstring muscle group. Now, the hamstrings generally originate or start at the posterior aspect of the pelvis, and they are going to insert in the posterior aspect of the lower leg. Now, if we look over here at this moving image, you'll notice the knee or the lower leg is moving closer to the hip. Therefore, whatever part of the muscles at the hip is the origin because it's on the more stationary bone, and whatever part of the muscles on the lower leg is going to be the insertion because it's on the moving bone. Now, we don't know really much about muscles, but if we look at this muscle and it starts at the posterior pelvis and goes to the posterior lower leg, we should be able to kind of assume what the action is. I'd recommend not studying or remembering or memorizing all the actions of every muscle, but if you do know where a muscle starts and stops, the origin and insertion, you can critically think about its actions. So for example, if this muscle starts in the posterior pelvis and goes to the lower leg, if I were to take the lower leg and move it closer to the origin, that would give me the action. So for example, if I want to move the lower leg closer to my butt, how would I do that? I would flex my knee. Therefore, the action of the hamstring muscle group is knee flexion. Now let's talk about muscles and movement. Now, anytime we move, there's going to be an agonist and an antagonist. An agonist, aka a prime mover, is a muscle that reacts and creates the movement necessary to complete a task, while the antagonist is a muscle that acts against the agonist muscle and helps to move the body part back in place after the action is completed. Basically, what I want you to understand is when one muscle is squeezing, another muscle is stretching. Whatever is working, there's an opposite muscle on the opposite side that is stretching. So if we look at this image here, we have the bicep brachii found in front or in the anterior aspect of our humerus, and on the back or posterior aspect of our humerus, we have the tricep brachii. Now, anytime you flex your elbow, we are going to be using the bicep brachii. So whenever you flex your elbow, the bicep brachii is squeezing. You all know this: flex your elbow, show me your muscles. That's the bicep brachii squeezing. What's happening at the same time is that the tricep brachii is relaxing and stretching. If we were to move in the opposite direction, though, instead of us flexing our elbow, we extend it, then the agonist would be the tricep brachii because it's the muscle that's shortening and creating movement, while the bicep brachii is then just going to be the antagonist because it is now being lengthened in that position. Depending on the movement required, a muscle can be an agonist in one motion and an antagonist in another. An agonist always contracts to initiate movement, and the antagonist always stretches and lengthens to allow the movement. Basically, a bicep brachii, for example, that's found in the anterior aspect of our humerus is not definitively labeled an agonist. It's only considered an agonist when it's contracting or squeezing, or when the insertion moves closer to the origin. So if you all flex your elbows and show me your muscles, that's the bicep brachii contracting or squeezing. In that situation, the agonist is the bicep brachii, and on the opposite of the bicep brachii is the tricep brachii, so that one is the antagonist. But go ahead and extend your elbow and reach backwards. We then just reverse the roles. When you extend your elbow, the tricep brachii is then the agonist, and the bicep brachii is the antagonist. Here's another visual aid. If you're interested, please pause the video so that way you have a moment to understand this picture. One thing I want you to understand is muscles can only pull, they cannot push. So for example, let's say we are doing some cable curls. When we are bringing that cable towards our shoulder, which means we are bringing our forearm towards our shoulder, we are going to be concentrically contracting the bicep brachii. It's the agonist. The opposite muscle is going to be the tricep brachii, and that's the antagonist because it's lengthening when the opposite muscle is squeezing. Then obviously when I go down and bring the cable down now, the tricep brachii is the agonist because it's the one squeezing, while the bicep brachii is now the antagonist because it's the one lengthening. Understand that no muscle in our body can push. So when you're doing, let's just call this a bicep curl for now. When you do a bicep curl, what's happening is that the bicep brachii is bringing the forearm towards the shoulder. It's getting you into elbow flexion. But when you go into an extension, the bicep brachii doesn't push away. It doesn't have that ability. Instead, the muscle on the opposite side pulls the forearm away from the shoulder. That's the action of the tricep brachii. So keep in mind, muscles can only pull, not push. Here's just a chart kind of giving you some examples of some agonist antagonist muscle groups. So if you're using the bicep brachii and it's the agonist, the antagonist would be the tricep brachii. If the agonist is the chest, then the antagonist is the back. Essentially, it's going to be opposites. That does conclude our presentation on the muscular system. If you have any questions, please go back through the presentation. If you still have questions, please reach out and I'd be happy to help.